Okay, so got the stream running. So today I'm going to be going over a basic version of what classes are and what objects are in C++. So it's like a super basic introduction to them. I'm going to use a very common example, like creating a fraction class. And if you don't know what a class is, it's basically you can bundle data into into an object that has member data and functions that are used to access that data and that only can be used by this object and the purpose of it. So in C++, you can represent data as like integers and doubles, but you can't represent information. There's no fraction type. So if you want to output something in the format of a fraction, you can create an object. Let's call it, you can create a class called fraction. And in that class, you can create data that's an integer that stores the numerator, an integer that stores the denominator, and then functions that can, change the values of this fraction or output the fraction in the format of like what we're used to seeing, which is like 1 over 3. Because C++ has no way of displaying 1/3 as actually 1/3. It'll display 0.33333 and then it cuts off at some point. And so there's no accurate way to really represent 1/3 unless you create a class. And that's what I'm going to be doing here. So let's first open up a header file. Just call it frac.h. And yeah, so in this frac.h file, we're going to declare the class fraction. And that's going to be the name of the class. Always do curly braces and a colon at the end of a class declaration. Don't forget the colon. And then we're going to have a public and a private section. So public is basically the this is the section that the user can use, like all the functions and stuff that the user can call, and it's available to the user. The private section is going to contain the data that the user can't access. The user can only access the private section through the member functions. So in a separate program, if we're calling this class, you can't. So in the private section, we're going to have the data for numerator and denominator. And if you're in like a different file trying to use this class, you can't directly access the numerator and denominator variables by just calling them, by invoking them. You have to invoke them through the functions in the public section. So it's like there's no direct way to access it unless you use these functions. So to start off, we're just going to create a constructor. Constructor is always just the name of the class itself. The default constructor has no parameters, so this is the default constructor. And it just initializes fraction. We're going to make it initialize fraction to 0 over 0. Or 0 over 1, because you can't divide by 0. So initializes fraction to 0. Then we're going to have another constructor, but with one parameter or two parameters. But so int n for numerator, int d, and we never want the denominator to be 0. So add a default value. If they don't add it, it's going to be 1. So it'll default to 1 if they don't add this parameter. But they have to add one parameter to call this function. So, and this is going to be constructor with one parameter. Now we can just create like an input function. And this will be to gain input from the keyboard, from the user. So we can input values into the numerator and denominator while the function is running, or while the program is running. So input fraction from keyboard. Wonderful. And now we're going to need a show function. This is going to, and it's a constant. So anytime you're not changing data, this doesn't change data. It's just going to output data. It's going to show us what's in the class, what's stored in it. So we declare it const at the end. And it's just like output num and denom. in proper format. And then accessor functions in get numerator const. So this is just, it's const because it is not changing data. All this is going to do is return the numerator. So we have a way to get that value because we can't access it directly. So we have to access it through a function. This will be that function. It returns the numerator. Same thing for denominator. Just returns the denominator. These are all just the declarations. And then we're going to have a way to set the value of the fraction. And int n, int d equals 1. So again, if they don't pass 2 parameters, d will default to 1. And this is going to set the values fraction through parameters. We're going to use this to initialize this. So you'll see why I set it to a bool in a moment. It's sort of for error checking. Double evaluate. So this is going to be a way, so we're not actually changing the data here, but we're going to output fraction in decimal form. That's just going to evaluate the fraction. Whatever data is in the object, we're going to print it out in decimal form. Useful. And for now, we're just going to add the private section. And we can overload operators and stuff. We can do that. Probably will get to that. For now, we just have like the show function. We could overload the insertion operator. And so we can output the fraction in a format we're all familiar with instead of calling the show function. So just in the private section though, we're just going to have 2 variables. Keep it simple. 2 variables, pretty basic. And let's go. So I think that's all I'm going to add for now. It's just like a basic overview. So now I'm going to open up a new file and call it frac.cpp. This is where I'm going to define these functions. So we need to have the declarations included in this, or else the compiler won't recognize when we try to run our program, it won't recognize, like it won't be able to link these definitions to the declarations. So in order to do that, we have to do pound include frac.h, and that just basically kind of just copy pastes. It's like a fancy way of copy pasting your information, your header file, into this file so that the declarations are here. And so what we're also going to include is IOStream. So we're going to do that because we're going to be working with IOStream objects and whatnot, like cout, cin. Or classes, I don't know. So IOStream, and then using namespace standard, because you always have to do that when you're using, say, IOStream. It's basically just anytime you use IOStream, you want to use namespace standard. It's like typically what you're going to do in these types of examples. And yeah, so now we're going to start defining the functions. So in order for this to know that this is of the fraction class, we have to do fraction colon fraction. So it's the scope resolution operator. It's so that we know that this, so this is the constructor with 0 parameters. We can't just do fraction parentheses. We have to put the class name before it and then scope resolution operator so that it knows that this function is of the fraction class. Fraction constructors of the fraction class. That's basically what tells the compiler that. So that it's not a standalone function. It indicates that it's part of a class. It's a member function, and so that's why we do that. And we're basically just going to do numerator equals n and denominator equals d. And if they don't, or no. See, I just made a mistake. Numerator equals 1, denominator equals 0. That's what we were going to initialize these two. So that's basically a fraction. No. Denominator to 1, numerator to 0. Simple mistakes. Set it so that the fraction is 0, basically. And from here, we're going to want to go on to our next function. Fraction, scope resolution operator. Fraction, int n, int d. And we don't add the d equals 1 here. You only do that in the declaration, not in the definition. So we already know that this is a default optional parameter, but we don't put the equals 1 part here. It's just part of the syntax. You only do that in the declaration, not the definition. So for this function, we're going to do something a little bit different. We're going to call the set value function. So what the set value function is going to do is a little bit of error checking for us. And it's basically, when we call it, it's going to set the fraction to n over d. But if the values are invalid, it's not going to. It's going to set it to 0. So, or it's not, it's going to return false. So if set value n comma d equals false, this means that if our fraction is divided by 0, basically, then we're just going to set value to 0, 0. Otherwise, it sets the value to numerator over denominator if it doesn't equal false, because then it returns true, and this function was called regardless, so we can just put it in the if statement. And not 0, 0, 0, 1, because we don't want it to dividing by 0, because that's denominator. 0, 1. Set fraction 0, 1 if it's false. So we're defaulting to 0 over 1 if invalid data is entered. And now, just to give you an idea of what we're doing with the set value function, I'll just do that one next. So, and then when you're doing functions that have a return type, because constructors have no return type, but the other functions do. So bool, it's always return type, and then class name, scope resolution operator, and then function name, set value, int n, int d. And here, we're just going to do a little bit of error checking. So if d equals 0, we're just going to return false and do nothing here. So if d is 0, return false and break from the function. Otherwise, numerator equals n, denominator equals d, and return true. So the reason why we did return false, so if d is 0, we return false. And what this does is, so when we run this constructor, say we want to create a fraction and we put 3, 0, then we go in set value 3, 0, calls this function set value, but d is 0, so it returns false, breaks from the function because we returned, comes back here, set value equals false, so we set value to 0, 1. Otherwise, if d isn't 0, numerator equals n, denominator equals d, returns true. This part never runs, and our value is set. So it's a nice little way to do some error checking. Ensure the fraction is always valid data here. And then for the next function, I'm going to do, let's do the input function. So it's void. It's a void return type. So return type, and then a class name, and then function name, void fraction input, and it's not constant. We don't do const. This changes data, so for that very reason, it's not const. And we're going to take input in the format of like 1/3 or 4/5. So in order to do that, we need to create a variable that's going to take out the slash from the input stream. And it's just a junk variable. We're not doing anything with it. It's just to get the data moving. So what we want to do here is create a do while loop. And in this do while loop, we're going to input numerator, and we can use the private data directly here because we are inside a member function. If we're not in a member function, we couldn't use numerator. It wouldn't be allowed. But because we are explicitly inside of a member function of this class, that's the only place you can access this information, so we're free to do that. Input the numerator, and then we're going to input the slash to get rid of it from the input stream, and then denominator. So, and we just get rid of the slash. We're not doing anything with it. We just take it out of the stream. And then if the denominator equals 0, so this is just a little error checking. We're going to output a little error statement and just say denominator must be positive. Try again. And this is why we have the do while loop. So we do this while denominator is equal to 0, because this is basically, we're running this loop and inputting it. If denominator is 0, we run it again. If the denominator is 0, we run this little error statement and input again until they get it right. So it's an infinite loop until they get it right. And once they finally enter a valid value for denominator, function breaks free and we input the data. Next function. So I'm going to do the show function next. So this is a void function, void fraction show, and it's constant. Doesn't change the data here. And we're just going to output the fraction in standard format. So cout numerator, and then a slash, and then denominator. And that's basically our show function. Not much to it. Pretty simple. And then we had our getter functions. They just return an integer, int fraction get numerator constant. Always remember the constants, and simply just return numerator. Same thing for int fraction denominator. Int fraction get denominator. Return the denominator. Simple stuff. And then the last one is evaluate. And I'm not sure. Okay. I just realized I don't know if the screen is fully in view here. It's not. That's a bummer. That's such a bummer, dude. So what I'll do is create a bunch of new lines so that it's now in view. In fraction get denominator, good. I wish I'd noticed that sooner because but we're gonna do double. This just returns a double. It returns the value of the fraction in decimal format. So can I spell right? Evaluate, and it's constant because we're not actually changing the member data. We're just outputting it in a different format. So we're just going to create like a new variable and return it as, so we don't even need to create a variable. We could just return the output in so like we could just return, what we could do is like say double D equals, well, and a more efficient way to do that, we could say double D equals numerator over denominator and then return D, or we could just do in one line return and then static cast. And then so what we're going to do is we're going to static cast, that's the format. We're going to static cast from a double integer to a double. So static cast double numerator over denominator. And what this does is it returns the decimal value of numerator over denominator. The reason this works is because we're converting the numerator to a double in this situation so that the output can be in double format. Otherwise, it would be integer division and we would truncate the decimal values. We don't want to do that. So static cast this to a double and then just divide it by denominator. And we return that value. So that's going to be the member functions here. And we can add a couple more, but for now, what we can do is just test it out in a little main function. So let's like open main.cpp. Create a new function, and inside main.cpp, we're going to want to include IOStream because we're going to be working with C and Cout. Include our header file. Otherwise, we wouldn't have our function declarations, and those are necessary. So got to include those so the compiler can recognize what we're doing here. Using namespace standard. And now here's our main function. And in our main function, always do return 0 first or else I will forget. Basically just lets your OS know that you're finished doing operations. The function is over. So now what we're going to do is declare a fraction. So to do that, we do class name and then variable name, fraction f1. This statement right here calls the default constructor. This syntax, when you just declare a fraction with no parameters, no parentheses at all. So fraction f1, it's going to just call the default constructor automatically. And it's going to create a fraction of 0 over 1. So we could say, just to see this, f1.show, use the dot operator to show it. We do the object name dot member function to call the functions on this object. And when we do that, just print an end line there just so that we have some fresh lines. This should output 0 over 1. And, you know, to make it a little bit more explicit, we could say cout f1 is f1.show. And we'll be able to see that. So, and then if we did fraction f2, but then this time we do 3, 4, say that. This is going to call the constructor with 2 parameters, and it's going to create a fraction of numerator 3, denominator 4. We can see that by saying f2 is, and then let's just do f2 dot show so that we can see it. And just do the end lines. I could do backslash new line, but doesn't matter. So doing this, we can compile. So I'll exit the file right now, and we can compile this real quick. G++-C frac.cpp. So we're compiling the frac.cpp file. Got an error. Let's see. Semicolon. So see, I added a semicolon at the end of that. I shouldn't have done that. So open up frac.cpp and go to get numerator. As you can see right here. Oh, wait, no. Wait, what was the error? Let me run this again. The error is line 10, get numerator constant. Oh, okay, yeah. See, I put the parentheses on constant instead of, so the parentheses don't go there. And it's not on line 10, I thought it was. So this is actually probably in my frac.h file because it's not here. So let's open frac.h. And we can see that is exactly what I did. So the parentheses don't go on the const, they go on the function. The const is just declaring it as constant. It's not part of the function's name. So now when we try this again, another error. See, I did fraction. Expected unqualified ID before. That's weird. So I'm going to open up the .h file and make sure that's fine. Fraction. That looks good. That looks good. So now let's go back into the CPP file. And it seems that the issue is right here. Yep. So what I did was on a definition, I added a semicolon. You're not supposed to do that. Only on the declaration. So that's just another simple mistake. Now when we go to compile it again, another error. Okay. Typo. Line 7. Numerator. Now let's do this again. And yet another error. Don't know why. Let's figure out. Fraction input, semicolon. See? Get rid of that semicolon. These are annoying little errors that you can, hard to catch sometimes. If you add extra semicolons, I think it's harder to catch than if you miss them for some reason. See, I probably did it. Forgot a semicolon there. See that? 35. It's like a lot of errors for such a simple piece of code. I don't know how I made that many errors. Kind of stupid. Making me feel kind of stupid. Compile it. There. Okay, it compiles. Now let's just compile. I swear there's gonna be like 10 errors probably in the main function. G++-C main.cpp. Of course. Let's see. Oh, okay, that's easy. So all I did was, this is why I like coding on a different terminal than Tectia, because I have the color coding and this wouldn't have happened. I forgot a slash, double slash for a comment. If it was in a different thing, a different client, it would have probably been highlighted blue for me, so I would have been able to tell that it was a comment. And let's just compile main again. It compiles. And now we need to compile them into an executable. So when we look at our list here, we have frac.cpp. We created .o files. So we created our object code. We need to link them now. So to link them, we just do G++. And then I like to do it in this format because it's easy to lose files sometimes doing this. So G++ frac.o main.o -o, and then let's just call it frac. So always after -o, we want our target. If you did G++ -o, frac o, main o, frac, we would have had compiled whatever this is into frac.o, because whatever follows -o is the target of what we're creating. And if I did -o frac.o, we would have just deleted that file. So that's why it's good to compile it into object code first also, and not like try to do shortcuts and stuff. If you did, you could do G++ .cpp -o frac, but if you made that error, you would delete your CPP file, and then you lost your entire file. You can't do anything about it, and it sucks. So run it, and it's exactly what we expected. F1 is 0/1, F2 is 3/4. And let's go back into our main file. And actually, I have a little thing that I wanted to show you. This is super cool. Just learned that you can use makefiles, vim makefile. If you open something called makefile, that's it. Don't do any extensions. Just open makefile. We can create a file that will basically, we can use the make command, and it's super, super convenient if you're going to be compiling a program over and over again. And what you basically want to do is, so first we're going to put like just the commands that are going to compile for us. So I'm going to put frac. This is our target. So frac : this is what we're going to create with this command. And then we put what is used to create frac. Well, if you were just watching, we used main.o. We used frac.o. So these are what was used to make it. Oops. And then below, do a tab and then type out the commands that you want it to run. So we're going to do G++ frac.o main.o -o frac. So it basically says when we run the make command, it's going to do this process for us and compile it into an executable called frac. But we don't have main.o or frac.o. We don't have these two files yet. So to add them into this make file, we got to do a target called main.o because we need to create that. And to do that, we needed to use two files for the target. We needed main.cpp, and we also needed frac.h for our header file. And then down here, we're going to do the commands that we ran to make this file, G++ -c main.cpp. And this is going to create our object code for main.o, or for main.cpp. And then the last one is we need frac.o. And our targets for this were frac.cpp, CPP, and frac.h. The command we ran was G++ -c frac.cpp. And then you just save it. And when you want to run this and compile your program, you just say make. And so I just typed in make, and it just did the entire compile process for us. So super convenient.
Now, if we open up main.cpp, we could run a couple more functions here. We could say set value. No, see, we got to call what object do we want to set the value on? Let's do f1 dot set value 2/3. Let's do 1/3. I don't know why. Let's just do 1/3. And then say, let's just show it now. F1 is now F1 dot show, and that's going to show our new fraction, but then also let's just output F1. So let's also do output F1 dot evaluate. Let's get the decimal equivalent of this. So F1 dot evaluate, and we use C out because it's a return statement. So we're printing out the return statement. And let's add a little bit of context here. F1 as a decimal is, and then what we can do is actually just cascade these. F1 as a decimal is F1 dot evaluate. And now if we clear and just type in make and then run our program, F1 is now I'm curious, why did it not? You see, I did it wrong. So we wanted to do F1. I don't know why it even compiled. It's really weird. 1,3. And then recompile it. Super convenient. Run this again. F1 is now 1/3. And as a decimal, it's 0.333. So, and let's just, so that we are not like bunched up on that line there. End of the line. Why not? Now what we can do is let's create an overload here. So we're going to use a friend function. Friends are always declared above the public section. It's the best place to do it. It's where I do it. At least it's kind of convention. And you declare it by saying friend, and then we're going to create an overloaded that operator, insertion operator, so that we can just say C out F1 and then output the fraction. So to do that, we need to do the return type of this function is ostream ampersand. So it's passed by reference always. And because we're using the ostream class here, we need to include iostream because we're using ostream. That's part of the iostream library. So friend ostream and then operator. The operator that you want to overload, you do operator, and then whichever operator you want to overload. So in this case, we're going to do insertion operator. You could do plus to overload the plus operator. We're just going to do insertion operator. Friend ostream and operator less than. And our parameters are going to be ostream and then we're also going to make the other parameter const fraction and f. So we're just going to pass it by const reference because we don't need an actual copy of the object and we're not changing it. So we can just pass by const reference and that works. And you know what we want to do here also? So we need to pass ostream by reference here because we are actually manipulating the ostream. So if we, so friend ostream and operator less than, ostream and s, a variable, const fraction and f. Now if we go into our other file, frac.cpp, we already have iostream included. Let's just go to the top and create this function. Let's define it. What's it going to do? So we already declared friend. It's not a member function, so we don't use the scope resolution operator. We're just going to do ostream and operator less than, and then ostream and s, const fraction and f. And then to define it, we're going to do, it's basically the same thing as the show function. We just put, what does the show function do here? And what it does is it outputs numerator, and then it outputs a slash denominator. And then return s, and that is for cascading our output, because whenever we return s, we're going to return a new insertion operator, basically, so we can cascade the output. And then come into the main and let's create a new fraction object, fraction f3. Let's do f3, and just make it 4, 5. That'll make the fraction object be initialized to 4/5. And let's just do this. Now we can do this. Instead of calling the show function, we can do cout f4 is, and then let's do f4. We can just output it with the regular insertion operator, just like any other variable. So that's going to work now. That's what overloading allows us to do. So if we break out of this file and make it, ran into an error. In file included from main.cpp, friend ostream and operator less than. Go back into main. Oh, I never even, because I did F4. F3. We didn't even create F4. F3. I think that might do it. Okay. Bunch of errors. What was the error? Does not name a type. Okay, so ostream and is the type. Let's see. That's weird. That's actually very weird. I don't know. So let's just open up our .h file and see. Friend ostream and operator listen, ostream and s, const, fraction, and f. Okay. But now, when I go into the CPP file, I have no idea. I've literally not. It's literally looks perfectly fine to me. Numerator slash denominator. Why is that doing that? Okay. I know why. So, see, I just tried to call numerator, but we need to call it for the parameter. So that's just a simple mistake. We need to call f.numerator and f.denominator. And that should fix it. Oh my gosh, my neighbor's going crazy with music right now. I don't know if you can hear that. Holy shit. Okay. I'm jamming now. He's got some good music going. Let's make this again. Yet again, another error. So, probably something simple. It's still not recognizing my function. So, let's see. In file included from main.cpp. Ostream and, that's clearly a type. I don't know what it's talking about. Does not name a type. Candidate. So, ostream and s const fraction. Okay, I know exactly what I did now. See, this was another stupid mistake. It should have been really easy. I shouldn't have made this mistake. That was like bad. So I used cout, but in this function, we need to use s because this is our parameter that we're passing in as, we're passing cout in as a parameter basically. So cout is one of our parameters, f is another. So when we say cout f3, we're basically saying this is parameter 1, this is parameter 2, and we're going to do this. We're passing cout in as s. That should fix it. No, how did that not fix it? I mean, I guess technically that makes sense, but let's see. If we, for an operator, F3 is, that's odd. So it's still something wrong with the declaration, I believe, or the definition. I don't know what though. It's going to be embarrassing when I figure out what this is. It's probably going to be, let's see. So the issue, I believe, is, let me double check here. That's really weird. Am I forgetting like a semicolon? So write an O stream and operator. That's really, really weird. Let's see. So let's go back to the CPP file. The error has to be in here. There's no way. There's no way it's not. So we have include frac.h, include IO stream, standard, O stream and operator. Less than, and then O stream and S, constant, fraction, and F. This is bothering me because this, I don't see anything wrong here. I see absolutely nothing wrong here at this point. It should be that's so weird. Why is it doing this? That's actually really frustrating. I don't understand. What the hell? There's clearly a type. Why is it just ignoring it? O stream is my type. It's not overloading properly. What did I just do? Okay. What did I do? All right. I'm gonna go back to the CPP file. This is gonna, oh my gosh. I don't understand. I don't understand. This is like the most retarded thing I've ever seen. That is not wrong. Oh my god, dude, this is so stupid. All right. I'm literally about to give up because this is retarded. There's nothing wrong with this function. It's going to be something. You know what it is? Did I include in my main file? That doesn't make sense. How does this make sense? I'm just going to try this. Get rid of all that garbage. Output F3. What? Dude, this is so annoying. Like this. Oh my god. All right. Oh, what is it supposed to be capital or something? Am I like I mean, it's literally word for word. There's nothing wrong with this code, so it doesn't make sense. Open this file again. I'm about to just delete the whole function and do this over again because this is super duper annoying. What does it mean there's no return type? Like, it's clearly right here. Oh, STREAM. Am I spelling something wrong? That's going to be pound in... Oh, wait, okay. God damn it. I didn't say using namespace. What a bummer. That's definitely it. Okay, so yeah, I literally just forgot to say using namespace standard. But now, when I run the executable, let's go clean this up a little bit. Let's say cout F3 is F3. And then remake this file. And F3 is 4/5. We have overloaded the operator. That was a stupid mistake. I shouldn't have made it. Partly why I don't like this terminal is because there is no color coding and I'm used to color coding. That was honestly, I don't even know if color coding would have helped that though. That was just a stupid mistake. But perfect. So now we've overloaded that operator. And that is basically an overview of how to create a basic class. We could overload a plus operator so we could add fractions. We could just say like F3 plus F2. And we could do that if we overloaded the plus operator. What we would do is essentially just say, instead of creating a function ostream less than, we would say operator plus, and then the parameters would be fraction F1, fraction F2. Then we would do F1.numerator and then add, what we would do like some conversions so that we can add the fractions together. So multiply F1.numerator by F2.denominator to get a common denominator. Same thing for F2.numerator times F1.denominator. And then we would add those two together and make that the numerator, and then make the denominator F1.denominator times F2.denominator. And then that would give us, or no, numerator times denominator, whatever. That would give us our common fraction. But for now, I think that's going to be it. I'm freaking tired. And let's see, is there anything else I didn't use in this? I didn't use the getter functions, but we didn't need to. We would use them if we were calling, if we just wanted to get the numerator or denominator in our main function, we could just use these. But yeah, I think I tried out every function. Tomorrow, I'm going to be practicing I'm going to create like a card game, blackjack, and I'm going to use like classes and stuff to create that. So I'm going to create a card class and then a deck class. In the card class, there's going to be ways to set the value of a card. So like set the value of a card and the suit of a card. And then that's going to be one card object. And in the deck class, I'm going to create an array of 52 card objects. And then I'm going to be able to set through the functions when I like create a deck object. I'm going to have to initialize it. And when I initialize the deck object, I'm going to have to set the suit and the value of the 52 cards. And there's ways to do that by looping and stuff. And then I'll have initialized the array of 52 card objects to give us the deck, and then I'm going to create a blackjack game out of that deck. So just good practice of embedded objects. And also going to be working on dynamic memory pretty soon. After that one, probably, I'll be showing dynamic memory how to sort of create dynamic arrays, but inside of classes. So yeah. Anyway, if you enjoyed watching this, I guess, cool. I don't know, give it a thumbs up. That'd be pretty cool. Hope you enjoyed it. Hope you learned something. I think I did a pretty decent job at explaining myself. If you're like a total beginner, maybe this isn't a good place to start. I'd start at maybe more like primitive stuff, working just with integers and doubles, loops for sure. Work with loops if you're beginning. Working with loops will give you a very good idea of how to code and how to like think about the logic behind code. But yeah, if you want to learn about classes, I feel like this is probably a pretty good explanation. And if you know about classes, this was probably boring as hell and just super, super easy. Anyway, I don't know. Hope it was useful. And I'll see y'all whenever. Probably, I don't know, probably tomorrow. Or, yeah. Peace out, guys.